radical expressions. So today when we talk about these radical expressions, they may have a square root, a cube root, a fourth root, a fifth root. And when I say an expression, that means that there's more than one term, right? So today we're going to talk about adding and subtracting, multiplying and dividing, at least binomials. All right? So let's talk about adding and subtracting first. 2, add or subtract. Radicals. They must be like terms. So they have to be the same in order to add them together. What I mean is, if I have, for example, 2 square root 3 plus 7 square root 3, those are like terms. So we just add the front number. That means we're going to have 9 square roots of 3. If I have 5 cube root 2 minus 9 cube root 2. Again, those are exactly the same. The label's the same. They're like terms, so there's negative 4 cube root 2. Okay? So that's what we're going to start with in our homework. Now, the whole idea is if they're not the same, we can't simplify them any further, right? If they're not like terms, we cannot simplify them further. And sometimes they may not look like terms, but you might have to check it out. So here's example number 1. It is. So example number 1 is going to cover all the way from 10 all the way to 22. So let's start with something as awesome as 5 square root 18 plus 9 square root 50. Well, now hold on. Hold on. So currently we can't add them together. They're not like terms. But we can simplify each of them and see what else can happen. So we're going to start with the first term. 18 we can break down into 9 times 2. And 9 breaks down into 3 and 3, which means we have a group of 3s that get to come out. All right, and when it comes out, we multiply with the 5. So our first term becomes 15 square root 2 plus 50 we can break down into 25 times 2. 25 is 5 times 5. So I have a group of 5s that get to come out. Easy, yes. 9 times 5 is 45, and I have a square root of 2. So now are they like terms? They are. We can go ahead and add them together. We get 60 square roots of 2. Let's try another one. Put it underneath the same example. Huh? All right, let's go with, how about 7 square roots of x to the third plus 9 square roots of x to the second y. All right, so let's see. We can't add them together right now, but we better simplify and check it out. We got to simplify first. Let's see what happens. Out of this one, we can take out a group of x's. So we have 7x square root x plus. Out of this one, we can also take out a group of x's. So we have 9x square root y. Are these like terms? Nope. So then all I want you to write is cannot simplify further. We'll just say cannot be simplified. We'll do that. Simplified. All right?
I'm sorry.
It's okay. Let's do one more. One last one. Let's go with the cube root of 81 plus we'll go 4 cube root of 24. So what is the first thing we have to do? We have to simplify if we can. So 81. Yeah. Okay. So in this first one, we're going to break it down into 9 times 9, 3 and 3, and 3 and 3. So that means I have a group of 3s, because I need 3 of them. So I have 3 on the outside. I still have a 3 left on the inside. Plus, let's go over here, 24. Breaks down into 6 and 4, 8 and 3, right? 6 and 4, that's 3 times 2, and 4 is 2 and 2. So you can take a group of 2s out. When I take it out, what does it do with the 4 out front, Irene? Good. So we're going to have 8 cube root of 3. Now can I add these together? We have 3 cube roots of 3 plus 8 cube roots of 3 give us 11 cube roots of 3. Pretty good? Yes. All right. So let's move on to the next part then. So we talked about adding and subtracting. They all follow the same thing, right? Right, exactly. Yeah. So let's go on to multiplying. Sample number 2. Yeah, but what we've been doing was only a single, like, monomial together. Yeah. So here's what we're going to do today. 24 through 32. I want you to simplify. We'll see. We have 3 plus the square root of 2 times by 4 plus, let's go 3 square root of 2. So I'm multiplying 2 binomials together. How do I like us to do it? The box. Very good. Let's put it in the box. So I have 3 plus the square root of 2 times 4 plus 3 square root of 2. 4 times 3 is 12. 4 times square root 2 is 4 square root 2. 3 times 3 square root 2 is 9 square root 2. And then square root 2 times 3 square root 2. 3 square root 4, which is 6. Very good. All right, now you'll notice in our box, the diagonal this way is going to add together first. 6 plus 12 is 18. And then we have 9 square roots of 2 plus 4 square roots of 2 is 13 square roots of 2. Huh? Yep, that's how you leave it. That's where it stays. It's just like when we were doing imaginary numbers, right? The complex numbers that way. Same thing. Do another one. How about sample number 3? I want you to simplify. 5 minus the square root of 3 squared. What does that mean? Yeah, this actually is saying we have 5 minus the square root of 3 times 5 minus the square root of 3, right? That's what that means, so we're going to throw it in the box. So 5 minus the square root of 3, and we're going to times by 5 minus the square root of 3. 5 times 5 is 25. 5 times negative square root 3 is negative 5 square root 3. 5 times negative square root 3 is negative 5 square root 3. How about negative square root 3 times negative square root 3? 3. Very good. A negative times a negative is a positive, and square root 3 times square root 3 is 3. Now we add our diagonals. Adding this way, 25 plus 3, 28. And how about negative 5 root 3 plus negative 5 root 3? Negative 10 root 3. Perfect. All right, so we talked about adding, subtracting, multiplying. What do you think needs to come next? Dividing. So before we get to the dividing, though, there is a word we used when we were working with imaginary numbers. It was the conjugate. Does anybody remember what the conjugate means? The conjugate is when you have a binomial in the denominator that's got a radical in it, right? So we have to use the conjugate to eliminate a binomial with a radical. So let's just remind you what the conjugate was. If in the denominator we had something like 3 plus the square root of 2, the conjugate was 3 minus the square root of 2. Just change the middle sign, right? If I have 4 minus the square root of 7, the conjugate would be 4 plus the square root of 7. If I had, how about negative 2 plus the square root of 5, the conjugate would be negative 2 minus the square root of 5. All right, so to get rid of it in the denominator, we have to multiply it by the conjugate. And whatever we do to the bottom, we're going to have to do to the course. Of course. So here is example number 4. I'm going to ask you to simplify. Let's say I have 4 over 3 plus the square root of 2. So if I have 3 plus the square root of 2 in the denominator, to get rid of that, I have to multiply by the conjugate. Good. 3 minus the square root of 2. Whatever I multiply the bottom by, I have to multiply the top by. All right. On the top, we can actually distribute that 4 through the parentheses. So 4 times 3 is 12. And 4 times negative square root 2 is negative 4 square root 2. Over. How do we multiply the bottom? Yeah. So we have 3 plus the square root of 2 times 3 minus the square root of 2. 3 times 3 is 9. 3 times the square root of 2 is 3 square root 2. 3 times negative square root 2 is negative 3 square root 2. How about negative square root 2 times positive square root 2? It is negative 2. It's negative square root 4, which is negative 2. All right. So what do you notice about this diagonal? The diagonal with the radicals in it. They cancel, and they should cancel every time. That's the idea of using the conjugate, right? So then we just have 9 plus negative 2, or 7. And that's our final answer. Okay? Do you remember doing these when we were doing imaginary numbers? Yeah, it's the same thing. All right, so do you guys need some more examples? No, we're good. We're good? Everybody solid? All right, so you have like 18 minutes. You can probably get a lot of this done if you get right to work in. All right?
I would like to keep right today. Sorry, Lucas. Because my soccer team plays at 4. And at 4 I start running. And I cannot run that distance thinking about my team. Second last in our division.
You'll be fine.
I will not be fine.